My dear student of 11th Science, in the previous physics class, we completed about the measurement of work done by constant force and also the nature of work done. Today we want to know the measurement of work done by variable force. Therefore, first you have to know what is variable force. Whenever magnitude of a force or direction of a force or magnitude and direction of a force is changes, then the force is said to be variable force. Now you have to know how can you determine the amount of work done under this variable force. For this, see the board very carefully. When a variable force F acts on a body along a fixed direction, this kind of variable force means the variable force along a fixed direction is represented in two ways. Number one, by an equation. See the equation. F of x equal 3x square plus 2x. Here f of x is a variable force because its magnitude changes with respect to the magnitude of x. Means this is a variable force along the x direction. So under this variable force, between any two position along x direction, if you want to determine the work done, then the formula is work done is equal integration initial position to final position f dx. Secondly, by a graph we can represent the one directional variable force. Okay, so now this is a force displacement graph. Under this variable force, why this is variable? See the graph very carefully. Magnitude of the force is changes with respect to position. That's why it is a variable force. Under this type of variable force, between any two position, say xi and xf, if you want to determine the work done, then you have to determine the area covered by the force displacement curve with the displacement axis between the two given positions. So therefore between xn and xf, the work done is equivalent to the area of the shaded region. Now when the force varies both in magnitude and directions, in these two situations, we determine the amount of work done under variable force whenever the variable force acting along a fixed direction. But if both magnitude and directions are changes, then how can you determine the work done? Then the formula to determine the work done is W equal integration S1 to S2 f ds cos theta. ds be the small displacement. Now from vector dot product, this equation can be written as integration S1 to S2 f vector dot ds. After measurement of work done, you have to know about the unit of work. Now there are two types of unit available for the work done: absolute unit and the gravitational unit. In absolute unit system, the SI unit of work is joule, and mathematically you can write 1 joule is equal 1 Newton into 1 meters. Means 1 joule of work is said to be done when 1 Newton of force acting on a body gives a displacement of 1 meter. Now CGS absolute unit of work is arc, and mathematically 1 arc is equal 1 dyne into 1 centimeter. So therefore 1 arc of work is said to be done by a force whenever a force of 1 dyne acting on a body gives a displacement of 1 centimeter. Now there is a relation between this joule and arc. The relation is 1 joule is equal 10 to the power 7 arc. Now in gravitational unit system, the SI unit is kilogram meter, and mathematically 1 kilogram meter is equal 1 kilogram weight into 1 meter. So therefore how can you define 1 kilogram meter of work is said to be done whenever a force of 1 kilogram weight acting on a body gives a displacement of 1 meter. the CGS gravitational unit of work is gram centimeter. Mathematically, 1 gram centimeter is equal 1 gram weight into 1 centimeters. Therefore, 1 gram centimeter of work is said to be done whenever a force of 1 gram weight acting on a body gives a displacement of 1 centimeter. Now student, you have to know the relation among the gravitational unit and the absolute unit of work, and the relation is 1 kilogram meter equal 9.8 joule and 1 gram centimeter is equal 980 arg. How can you determine these relations? To convert gravitational unit to absolute, you have to multiply the gravitational unit by the magnitude of accelerations due to gravity. That's why these two relations. Now, the dimensional formula of work W equal mL square T to the power minus 2. Now student, you have to know a very important concept known as conservative force. To understand about the conservative force, see this diagram very carefully. Here an object is traveling from A to B over two different paths. APB is path 1 and AQB is path 2, and the displacement of this object under these two paths from A to B occur under a force, and that force is said to be conservative if the work done in displacing the object from A to B under this force only depends on the initial and final position, not depends on the nature of the path followed. Okay, so therefore a force is said to be conservative if the work done under this force in displacing an object from one position to another position is only depends on initial and final position, not depends on the nature of the path followed. Then the force is said to be conservative. Now, here we consider under a conservative force, an object is traveling from A to B via two different paths APB and AQB, and as the force is conservative, therefore work done in displacing the object from A to B via these two different paths are equal. That's why we can write an equation like integration A to B F vector dot dr, path is APB. So this represents the amount of work done along the path APB should be equal to integration A to B F vector dot dr, path AQB. This represents the amount of work done via the path AQB. Now student, I want to change the path AQB to BQA. So whenever you change the path from AQB to BQA, it becomes minus. And limit of the integration also becomes reversed. Okay, like this. This side remain as usual, and see this portion. This becomes minus whenever limit are changes, that is B to A, and path becomes reversed, that is path BQA. Clear? If we move this term to the left, it becomes plus and right hand side becomes 0. Okay, and now see here, this is integration from A to B plus integration from B to A. Means if you add these two equations, you got an integration around a closed curve C, and this C closed curve is, according to this diagram, APBQA. Clear? So therefore integrations over closed curve C, F vector dot dr vector is equal 0. So this is the another way by which you can say whether a force is conservative or not. If the work done by a force around a closed path is equal 0, then the force is said to be conservative. Now student, in vectors there are some important theorems. Okay, so one of these theorems is Stokes theorem. Using the Stokes theorem, this line integration can be converted into the surface integration. Therefore, the left hand side of this equation using the Stokes theorem can be written as surface integration curl of f vector dot ds vector. This is called curl of f. What is this? This is a new vector operator known as del operator, which can be written as del operator equal I cap del del x plus j cap del del y plus k cap del del z. This is a new vector operator known as del operator. Now student, as this force is conservative, this is equal 0, so therefore this is also 0, and from this equation we can write curl of f equal 0. This is another way by which you can say whether a force is conservative or not. If the curl of a force is 0, then you can say that force is also conservative force. That force is also conservative force. Okay, now some example of this conservative force are gravitational force, electrostatic force and elastic force. These are the central force, and this type of force are the conservative forces. Now student, one important numerical depending on the concept of variable force. See the numerical. A particle moves along x-axis from x equal 0 to x equal 5. Means x equal 0 is the initial position, x equal 5 meter is the final position. Under the influence of a force f equal 7 minus 2x plus 3x square. Just see, this is a variable force. If you change the value of x, magnitude of the force is also changes. Find the work done in this process. We know the formula whenever the variable force gives like that. The formula is W equal integration initial position to final position f dx. So according to this formula, W equal integration initial position 0, final position 5 f dx. Now put the value of f, that is 7 minus 2x plus 3x square into dx. If you perform the integration, here it is gives 7x minus 2 into x square by 2 plus 3 into x cube by 3. Okay, lower limit, upper limit. First you have to put the upper limit, then a minus sign, then you have to put the lower limit. Now see, therefore W equal upper limit is 5, so 7 into 5 minus 5 square plus 5 cube minus lower limit is 0, means this is 0, this is 0, this is also 0. So after calculating this, we got W equal 135 joule. Okay, now student, read this portion very carefully. Okay, I will provide some numericals for the calculations of work done under variable force. Thank you very much.